When you're finding the equations of the line's tangent at the pole, first of all, a graph is very helpful. Second of all, where are these tangents? This is the tangents at the pole. Where are they? The tangents that take place at the pole. Our origin. Okay, you can see, so that's why it's helpful to graph this as one smooth curve, because yes, there is a unique tangent line at that point. To find the equations of these blue lines, here are the steps, the tangents at the pole. We're going to make r equals 0 and solve for theta. Because tangent of theta is y over x, I could multiply both sides by x and get a real easy way of writing an equation if I'm just given a theta value, which is what I'm going to have. So this is the easy way to put it into an equation. So once we get our thetas, we're going to plug it into y equals tan theta x. Those will be my tangent lines. Ooh, it's a multiple angle one. Fun. Well, first I'm going to divide both sides by 4. Sine of 3 times theta is equal to 0. Now, the way that we solved this is that we would grab like another variable such as x. X might be a little confusing in this case, so maybe I'll use alpha. And I'm going to say alpha is equal to 3 theta. If alpha is equal to 3 theta, then now all I'm doing is really solving this equation. That equation is not too hard to solve. Sine of alpha equals 0? Sine of what equals 0? Okay, so for multiple angles, we do like to write all possible solutions, 0, comma, pi. So usually I would write it as the first thing plus 2 pin. And then I would write pi plus 2 pin. And those would be my 2 results. And then I would plug in different values for n. Do you remember this from Algebra 2 trig? But here's the thing, 0 and pi are only pi away from each other. So I can actually write 0 comma pi as just being pin, pi n. Because if I plug in 0, I get 0. If I plug in 1, I get pi. And then if I plug in any integer after that, I get all coterminal angles to 0 and pi. Let's plug in alpha. Alpha is 3 theta. I'm trying to get theta by itself. So I have an expression for how I can find the solutions of which angles give me the slopes of my tangent lines at the pole. Ooh, okay. So I have theta is equal to pi thirds n, or pin thirds, or whatever you want to call it. And now I'm going to plug in different values of n. N could equal 0. And when n equals 0, theta is equal to pi thirds times 0, which is 0. Plug in 1, and we've got pi thirds. When we plug in 2, we get 2 pi thirds. The theta values for which there are tangent lines at the pole would be 0, pi thirds, and 2 pi thirds. The equations of my lines are y equals tangent theta x. So if I take y equals tangent of 0, x, that equation, tangent of 0 is 0. So y equals 0 is the line. Do you see a line that is y equals 0? Yeah, I see a line, a tangent line at the pole that's y equals 0. Next one, let's plug in pi thirds. Yes, root 3x. Do you see a line, a tangent line that looks like it could be root 3x? Yeah, this one right here looks like it's y equals root 3x. Now it's tangent of 2 pi thirds. So that's negative root 3x. Do you see a line, perhaps, for which the equation is negative root 3x? Yeah, this one looks like it's negative root 3x. So why do I stop? I have 3 tangents and I have 3 equations. I don't need to keep going. If I plugged in pi, I would end up with tangent of pi x, which is 0. So I'll just end up repeating the tangents over and over and over. So you know when to stop when you have covered all of the tangents that you see, okay? If there were 3 tangents, we only really needed to plug in 0, 1, and 2 to cover all our bases. These are the equations of our tangent lines at the pole.